Alright guys, welcome to day 2 of Build a Robot Arm. So we're going to go ahead and do a quick review from last week, and then I'm going to add in a few more things. Alright, so here are my notes from last week. We did the robot arm, just introduced that. I explained how we're going to build a robot in this class, and there are actually 4 types of engineering that we're going to learn: electrical, mechanical, computer, and software engineering. And I also said that we're not just going to build a robot, we're also going to learn career skills. And career skills, if you remember, those are the things that you can take outside of the classroom into a future job or into life in general. And I named 3 different things. You're going to learn how to fix things, you're going to learn how to innovate or to create new things, and you're also going to learn to share or communicate your ideas. Okay, and then during our live session, I shared a little bit about some of the things that I actually fixed in real life. So we're going to continue to do that. So each week I'll share a little bit, maybe 1 or 2 things that I've actually fixed in my real life, so that I can give you guys an idea of what it's like to fix something, and also the advantages of fixing things, because it's pretty cool. And then I'll also challenge you guys to fix some things throughout this course as well. All right, then the next thing that we talked about right here was closed circuit versus open circuit. So closed circuit, if you remember, that's when there is a closed loop, and this is the battery right here. If there's a closed loop, that means electricity can flow all the way through from plus to minus, and the circuit turns on. For the open circuit, it's the opposite, meaning there's an opening in your loop, so that means electricity tries to go but cannot make it all the way, so then it stops, and in fact electricity doesn't come out and your circuit is not on. So using this concept, we then built a LED circuit, and we used 5 volts from the Arduino, and we used GND. 5 volts is going to be the plus, and GND is the minus, and that acts as our battery. We put our light in there, our LED. One side was plus, which was the red wire, and one side was minus, which is the black wire, and then it turned on. So just as a refresher, let's just do that real quick. All right, so here's our Arduino here, and then we had to use our socket to pin wire. So let's go ahead and do that. Okay, we got 5V. There's a bunch of them. I'm going to use this one right here, 5V. And then I got to get a breadboard. I got a blue one today, okay? So then I'm going to just pick a row right here. And remember I said, you know what, there's 2 sides. There are 2 sides to this. We're just going to ignore this one side. We're just going to use one side for now. So don't worry about what that other side is. The key here, just real quick, if the hole is on the same row, this group of 5, those 2 holes are connected, okay? And if they're not on the same, if 2 holes are not on the same row, they are not connected. Okay, so let's go ahead and put the GND. So I'm going to put GND right here. All right, and I'm going to put it on a different row. So not on the red wire, right, but a different row. I'm going to put it down here, the one right under it. Okay, so you can see they're different rows. Okay, now we grab one of our LEDs, okay, and remember there's a black and a red, so let's make sure we follow our schematic here. Black, which is minus, goes to the GND row, red to the 5V row. So I just go ahead and do that. Boom, like that. And it should turn on. The problem is I don't have power right here. So let's go ahead and do that. I got a USB cable connected to my computer. This is a black one. Yours is probably blue, but no worries. They're the same. Okay, so I plugged it in and the light is on. Okay. So that's a quick review. Now let's go ahead and do the next step. So in class I talked about, well, so what is it possible to connect two lights at the same time? And I saw that some of you guys did that through experimentation. Okay, so which is super cool. Now let's go ahead and do this again. So if we want to add two LEDs, let's actually draw out what that looks like. So what you do is you need to connect a second LED like this. All right. So this is called a parallel circuit. We touched upon this a little bit. I'll write that right here. Parallel circuit. Okay. So what's going to happen is electricity is going to come out of here. And then what happens is it's going to have two paths to go. It could either go this way or it can go that way. And here's the thing. They go here, so this path goes, and then right here it meets up again and then comes back. Okay? Now the reason it's called a parallel circuit is because we have two parallel paths for the current. Okay, so you got a path this way, and they're right next to each other. So it's called a parallel circuit. Okay, so let's go ahead and try this. And what I want you guys to get really accustomed to is going from this drawing to real life over here. All right, this is the design. Design is when you plan ahead, when you think about where you're going to build before you build it, and then this right here, but the breadboard is the actual circuit. Okay, so this is the design, and then the actual circuit. And actually, I'll just put that word out. It's called schematic. Okay, schematic means the plan or the design of a circuit. So this is a schematic because on the drawing, it's a plan. It's not the actual physical thing. The thing that we actually build, that is the actual circuit. All right. I'm going to ask you these things later, right? So make sure you're taking notes. So design or the drawing is a schematic. The actual thing that you build with electricity going through, that's the circuit. Okay, so now that we have this design, let's go ahead and put a second one. So I got my second one here, and then you got to match it up, right? So again, on my second one, the black wire or the minus goes with the minus of this light, which is also connected to GND, and then the plus goes with the plus of this light and also the plus of the 5V. All right, so then I put it in, and let's go ahead and make sure I do this the right way. There you go. We have two. All right, now I want you to think a little bit. So what do you think is going to happen if I put it in the wrong way? Well, probably won't work, right? See? So it doesn't work because I put this, it doesn't match, okay? So if your lights ever don't work, you gotta check your wires, make sure you have the plus and minus on the light correct. All right, so here's your challenge, and I gave you a hint last week. Go ahead and draw what the parallel circuit would look like, but with 3 lights. You have the drawing here with 2 lights, right? But what does it look like with 3 lights? All right, so that's your challenge. Okay, now let's go ahead and I'm going to take it to the next level here. Okay, so let's now create a situation. And this next situation is going to be called a series. And I'm not going to say circuit anymore. Well, okay, yeah, I'll say circuit. That's all right. I was going to say I'll call it schematic, but that's okay, because I want you to first teach you the concept of a series circuit first. Okay, so a series circuit is not the same thing as parallel. They're different words, so obviously it's different. But let me draw for you what a series circuit's going to look like for our LEDs. Okay, so our battery, just like it was before, and we go like this. Okay, LED 1, LED 2, like that. Okay, so what do you see here? I want you to look at this. What's the difference? Series circuit, you got two LEDs. I'm going to bring back the parallel. Check out the parallel. Also two LEDs. So the main thing I want you to notice is that the parallel, they're next to each other. And what happens is you have two paths for electricity. The electricity can either go route 1 or route 2, and then they meet together. But if you look at the series circuit, how many paths of for electricity are there? How many routes? Let's go out here from the plus, and it goes here. There is only one path. So what's going on in the series circuit is that there's still only one path, but there are two LEDs. All right, so let's go ahead and try this out and see if this works. Now this gets a little bit more tricky, okay? I got my Arduino here. Okay, this gets a little bit more tricky, all right? So right now this is just with one LED. So what I need to do, I'm going to take this out. And I'm going to take out the minus. So right now all I have is this red wire, which is the 5V. So when we start making a little bit more complicated circuits, it's good to start with the plus of the power and then just kind of walk your way through the schematic, right? So start here and then make the connections as going all the way through like this. All right, so we got the plus, so that's here. Now we follow along. Where does the plus connect to? Okay, it connects to the plus of this light. Now just to be more clear, I'm going to call this LED 1 and this one's LED 2. Okay, so LED 1, I'm just going to say, I'm going to put my two LEDs here, all right? This is going to be my LED 1. Okay, so what's going to happen is that this red wire needs to connect to the plus of LED 1. So that's going to be the red wire right here. So I'm going to connect it here. Boom. All right. Now, I've just made this connection right here from here to here. Now let's keep going. Let's make the next connection, the minus of LED 1. Well, the minus of LED 1 is going to be this black wire, which is on the second row right now. So the black wire right here is on the second row. That needs to connect to the plus of LED 2. See, this is where, if you're not careful, it starts getting confusing, right? So we got to go one step by step. So this one is LED 2, this guy right here, and we got to connect the plus of this one, which is the red wire, to the minus of the previous one. So I go like that. Okay. See, now you see why I took the black wire out from the Arduino earlier. Because if I left it in there, it would have got messed up. Okay. Okay, so now we've made this connection. Now let's make this connection. The minus of LED 2 needs to connect to GND. So the minus of LED 2, which is, that's the minus of this wire. Okay. that needs to go to GND. So this is my GND. Let's connect it. Get it on the right row. So I'm actually on row number 3 now. If I do that, it should turn on, and they are both on. Now, you may not be able to see it on the screen with here because I have these bright lights on above me, but it actually seems a lot dimmer than when we did the parallel circuit. Okay, so when I did this circuit, the lights were brighter, and then when I did it with the series circuit, it still turned on, but it seems dimmer. Okay, so I want you to think about that. Why would it be like that? Like, how come when it's parallel, when there are two paths, it's brighter? All right, so that's something to think about. I'll give you guys the answer on Thursday, but I want you to give that some thought. The other challenge, so I'll just write this. 1. Why dimmer? Okay. And then number 2. Try with 3 LEDs. Okay? So when I say try with 3, from now on, whenever we're building circuits, I want to see a schematic and actual circuit. Okay, so that means, what does this drawing look like if you have 3 LEDs in a series circuit? And then once you've drawn it, try building it to see what happens. All right, I'm not going to give you the answer, but we'll chat on Thursday. I'll give you the answer on Thursday, but give that a shot. So what does it look like with 3 LEDs in terms of the drawing, and then try it out and see what happens. All right. Okay, great. And let's talk about one more thing here before we move on. So there's actually something that I didn't quite tell you about, and that's this, guys. If you look at the LED, if you look closely, this is the light. That's the part that lights up. If you look right here, there are 2 black legs here, and they have this plastic or insulated shielding around it. All right, one side looks pretty smooth. The other side is kind of bumpy, right? It's got this object in there. Okay, so I didn't really tell you about that thing. That thing is actually this thing. And this thing. This is another example of that thing in there. All right, some of you guys may know what that is. I'm going to write it. This thing is a resistor. All right. I didn't want to get into all that right away because, sometimes you just want to get it working and so we can learn some of the concepts. But now I'm going to actually go inside and explain what's going on inside of here. Okay. So the resistor, what is the role of the resistor? I'm just going to give you a definition and then we'll stop there for today. All right. So a resistor resists or same as slows down electricity. Okay, so if you think about this, why would you ever want to slow down electricity? Well, the reason that you would want to slow down electricity is this. Let's say you have power, which you do, coming out of the Arduino, okay, and it's going into this light. All right. So you want enough electricity so that it turns on. But what happens if you put too much electricity, or electricity is going through the LED too fast? What can actually happen is the LED can burst. So have you ever seen electronics, if they get fried up or they get burned up, it's because there's too much electricity, or the electricity is going too fast through the component, and it heats up and burns up. If you ever hear on the news when there are fires, things like that, they might say the cause of the fire was an electrical fire. What that means there is that there's too much electricity going through something in the house or a building, and it's heating up so much that it's causing a fire. So one thing that you can do to fix that situation is to add a resistor. All right? So that's why you need a resistor. Part of it's for safety, so that your circuits don't heat up or burn up, and then part of it is for design too, because sometimes, for example, like this light, sometimes you might want it to be dimmer. So that's another thing I want to kind of point out. If electricity is being slowed down in the circuit, what do you think happens with the light? If there's less electricity, or the electricity is just trickling like really slowly, the light is going to be dimmer. And the opposite's true. If there's a lot of electricity, or it's going really fast through it, then the light's going to be brighter. So the resistance, or the value of the resistor, so that means depending on how big the resistor is or how small the resistor is, that can control the brightness of your LED. Okay, and there are times where you might want to make a light dimmer. For example, maybe it's some kind of warning sign, right? So if the warning is, let's say you're running out of gas, let's say, right? So if you're in your car, and if you're just, you still have a lot of gas left, but it's kind of wants to tell you, it's like an indicator to tell you that you're almost, like you're kind of getting to a place where it's starting to get low. Maybe you have an LED like turn on, but not too bright, okay? But then maybe when you're almost empty, you want the LED to be super bright, okay? So those are common, that's a common example of why you would want to use a resistor to control the brightness of an LED. So it's not always that you want it super bright. All right, so that's good for today. So today we learned about parallel circuits. And just to recap here, we also learned about series circuits, and we learned about resistors. All right, that's it for now. I'll see you guys soon.